This video is sponsored by Wren. Hello and welcome to this episode of Night Sky News for June 2022 with me, astrophysicist Dr. Becky Smethurst. This is the show where we chat about what you should look out for in the night sky in the next few weeks, and we chat about what's been happening in space news in the past few weeks. Any scientific research papers I mention are all going to be linked in the video description down below, and there's chapter titles down here if you want to skip ahead to any specific news story, because before we dive into this, I just want to tell you that I have some new merch. My graphic designer sister Megan has been hard at work making 2 new James Webb Space Telescope themed designs. This one of the hexagonal mirror array with the reflection of the first near-cam alignment image in it. I absolutely love the colours in this one. And then this design playing on the hexagonal theme, celebrating the successful or nominal launch, the instruments on board, and some of the science that James Webb Space Telescope will do. These are available along with the original 3 designs, my logo of a galaxy reflected in my iris, my precious toenail moon, and of course, space is hard, words are harder. You can get them at this link, which is also in the video description down below. I'm now using T-mail for my merch. We're all about sustainability with plastic-free packaging, organic cotton, and a recycling scheme for old products as well. So the environmental impact of my merch has been lowered at least as much as possible, and you guys get a better quality product than before. Anyway, without any further ado, let's kick things off and start by looking up. So we've just passed the summer solstice here in the Northern Hemisphere, which means the nights are getting longer and longer from here on in. Music to an astronomer's ears. But of course, the sunrise is still incredibly early in the morning. It's around about 4 a.m. here in the UK at the minute. So spotting early morning sights like the 5 naked eye planets that are currently visible all in a row is a little bit difficult. But for those of you further south with later sunrises, you'll have a great view. And at this time of year, the planets will rise higher in the sky the closer you are to the northern tropic. In the southeast from the horizon up, you have Mercury, Venus, Mars, Jupiter, and Saturn, all visible with the naked eye and will stand out from the background stars. Venus and Jupiter are going to be the brightest of all of those 5, so if you can find those, you can spot the other 3 from there. If you have a telescope, Uranus is also knocking around here somewhere between Venus and Mars if you want to have a go at finding it. Now, the moon is also joining this planet party right now as a very thin crescent moon, or a toenail moon, as I like to call it. Friday the 24th of June, it's going to be halfway between Venus and Mars, so that might make finding those in the sky a little bit easier. And then it's going to get steadily closer to the horizon and closer to Venus through the 25th and the 26th of June. Venus is also just under the star cluster Pleiades at the minute as well. It kind of looks like a little mini plow or Big Dipper constellation for those who are familiar. But in fact, it's like thousands of stars all clustered together. So the 3 of those, Pleiades, Venus, and the Crescent Moon, all clustered in one spot like that would make a great astrophotography shot. Just saying. Now, because Saturn is so far up that chain of planets at the minute, it does actually rise at around about midnight at the moment. So keep an eye out in the southeast if you're more likely to be up late than early, and you might still spot Saturn. Otherwise, at this time of the year, the best thing to look out for in the sky is the summer triangle of the 3 brightest stars in the sky: Vega, Altair, and Deneb. They're usually some of the first stars that you can spot after sunset because they're some of the brightest. They're in their own separate constellations, but they do make this really nice big triangle shape in the sky that's dead easy to pick out. If you're struggling to find the summer triangle, best thing to do is just download one of those free star chart apps on your phone. It'll know your location and you'll just be able to point it at the sky and it'll tell you exactly what you're looking at, and hopefully you should be able to find the summer triangle from there. Once you've found it, one of those stars, Deneb, is in the constellation Cygnus, the swan. It's actually one of the constellations that actually looks like its name or what it's supposed to be. And I like to find this because if you follow the line of the neck of the swan, almost sort of like the long bit of the cross that this makes, that'll actually trace the path of the Milky Way in the sky, and it makes spotting the Milky Way that much easier if your sky is a little bit bright due to light pollution. Then one last thing, on the 14th of July, we're going to have a full moon, which is going to be close enough to Earth to be classed as a supermoon. So this is when the full moon occurs near perigee, the point in the moon's elliptical orbit where it is slightly closer to the Earth than normal. This is going to mean that the moon will be slightly larger and brighter in the sky. Our eyes are not sensitive enough to be able to pick out that the moon will look ever so slightly larger on the sky, but they are sensitive enough to be able to pick out the fact that it will look much brighter, especially if you have a clear night. If you're away from, city light pollution, one of my favorite things to do is to look and see if I have a moon shadow on the full moon. It's a really fun thing to do with kids as well. All right, that's enough for looking up at the night sky. Let's come back down to Earth now and chat about what's been happening in space news in the past month. There is so much to talk about this month, but let's start with our usual James Webb Space Telescope news roundup. So NASA announced that the first science images from Webb will be released on July the 12th, after all of the commissioning for all of the different instruments on board the telescope are finally complete. So that is going to be a really exciting day. It falls right in the middle of the largest astronomy conference in the UK as well. So I'm going to be bringing you reaction from myself and from my colleagues of when all those images are released during that week on this channel. So make sure you subscribe so you don't miss out on that. You might also have seen this month that Webb was hit by a micrometeorite, causing minor damage to one of the mirror segments on the telescope. I made a YouTube short about this with all of the details in if you want to check that out, but essentially they know that this has happened just because of a slight change to the image. The image is degraded ever so slightly, but it's nothing to worry about because they can correct for it, and the telescope is still working way better than they ever expected it to, so it's still going to be able to achieve its science goals once the commissioning is done. Commissioning is very nearly almost done, sort of all of the tweaks to the various different instrument modes to make sure that they're performing at their peak. At the time of filming, they're almost halfway through with 7 of 17 instrument modes completed. You can actually track it on the Where is Webb website, which I'll link in the video description below. Once they're all done with commissioning, the telescope operating team will start working through the big long list of targets from proposals that were successful and were awarded time with the telescope, and that's where the real science will begin. It's also conference season in academia now, that we're out of term time, and so some of the biggest astrophysics conferences in the world are happening right now, actually in person for the first time in a couple of years as well because of COVID. So last week was the Summer American Astronomical Society meeting in Pasadena, California. Next week is the European Astronomical Society meeting in Valencia, Spain, and then there's the UK National Astronomy meeting in July at Warwick University in the UK. So you're going to see a lot more astronomy news stories in the media just due to all the press releases that tie in with someone who's giving, like a research talk at that conference. But you're also going to see a lot of chat about unpublished, results that are not peer-reviewed yet on all of the social media hashtags from people presenting, preliminary results at the conference that they're sort of, teasing people with to hype up a research paper that they know might be coming out in a couple of months. So for example, do you remember a couple of years back, there was that claim of a detection of phosphine in Venus's atmosphere? And we have no way of explaining this. There's no known chemical or geological process that we know of that can produce phosphine. On Earth, all of the phosphine is made either artificially by humans in industrial processes, or it's made by microbial life. So people got probably a little bit overexcited that this result meant that there might be microbial life in the atmosphere of Venus. But then another group challenged that claim, saying they'd reanalyzed the same data and didn't find any evidence for phosphine. So then, last week at the American Astronomical Society meeting, Jane Greaves, who was the lead author on that very first study claiming that detection of phosphine in the atmosphere of Venus, gave a talk at the meeting, and in that talk showed some new data that had not yet been published that was taken back in 2020 with a different instrument and analysed in a whole new way, and it still showed evidence for phosphine in Venus's atmosphere. And she said they're planning to do an extended 200-hour study with the JCMT, the James Clerk Maxwell Telescope on Mauna Kea in Hawaii, to try and track this. So when the results of that study come out, we'll know a little bit more, and I'll report back here on this channel what they find. In the meantime, if you want to check out all the press releases from the American Astronomical Society last week, I'll pop a link in the video description down below. On top of all those press releases, this month there's also been a huge data release from the European Space Agency's Gaia mission, which aims to record the positions, movements, and velocities of over 1 billion stars to try and produce a 3D map of the nearby section of the Milky Way. In this latest public data release, they provided the most precise positions we've ever had for over 1.8 million astronomical objects, from stars in our own Milky Way to quasars outside the Milky Way. And fun fact about Gaia, it is also at Lagrange point 2, 1.5 million kilometers away from Earth, keeping the James Webb Space Telescope company. It's been there since 2014, and in all that time, it's also been dealing with micrometeorites, just like the James Webb Space Telescope, and Gaia is still working just fine. Now, along with all these precise positions you get from the imaging data, they've also released a load more spectroscopic data, where you split the light from a star through a prism to see how much light you have at each wavelength or color. And that data has so much more information encoded in it. You can use it to get at the temperature of the star, or the age, or the chemical composition of the star as well, i.e. what is the star made of? How many heavier elements like carbon and iron does it have compared to hydrogen? And so what you can then do is make this complete census of the stars in the Milky Way. You know, what are they made of? How old are they? And where do we find these different types of stars? So we can try and piece together sort of the evolutionary history of the Milky Way. For example, here's a plot from one of the data release papers showing how fast stars are moving around the galaxy against how fast they're moving radially, i.e. in and outwards in the galaxy. You can see you've got these two distinct clumps of stars. You've got the main spiral disk with both high angular speeds and high radial speeds, and then another clump with just high radial speeds. And this has been nicknamed the Gaia sausage. And we think that these stars are the remnants of a much smaller galaxy that merged with the Milky Way a long time ago, and so have these very different orbits. Now, there's so much data that's been released here this month, and so who knows what unexpected things that people will find in it once they start mining this data. I'll actually put a link in the video description to where you can access the data online if you want as well. It is completely public and free to access. So I'm really looking forward to, in the next few months or year or so, reading all of the research studies that get published using this data and seeing what people find. Speaking of things in the Milky Way, this month 2 studies, one by Sahu and collaborators and one by Lam and collaborators, both claim to have found a rogue black hole wandering interstellar space. Both papers reckon it's around about 8,000 light years away, with a mass up to about 4.4 times the mass of the sun. So it's a pretty cool discovery that they've spotted here in Hubble Space Telescope data. Now, by definition, black holes don't emit any light, so they're really tricky to spot. Usually we can only infer that they're there when they're in binary systems, so they're orbiting another star which they can steal matter from, accelerate it to huge speeds, causing it to glow in UV, optical, and X-ray light, and pretty much light up these black holes like a Christmas tree. But rogue black holes don't do that. We don't think that there's enough material in interstellar space for it to be dense enough around the black hole for it to, glow brightly enough for us to be able to spot it. But we still reckon there's around about 100 billion of these rogue black holes in the Milky Way that are left over from when a massive star ran out of fuel and went supernova and the core collapsed down into a black hole. So to find them, we have to wait for a very rare chance alignment of a black hole with a background star. The black hole can briefly brighten that background star, bending the light to focus it on Earth like a big magnifying glass. But no one knows where in the sky those events are going to happen or how long they're going to last for. They could be incredibly brief and fleeting, or they could last for a little bit longer, in which case we'd have a better chance of spotting it and then monitoring it for a long time. So half of this is just luck that you have a telescope pointed in roughly the right direction to be able to spot this. Now, this time, it was both the Ogle survey and then the Hubble Space Telescope that captured the brightening of a source called OB110462. So it's first noticed to be brightening in the Ogle survey, and then they monitored it further after that. So the blue dots in this graph are showing the data taken over a 2-year period, so this alignment actually lasted for quite a long time. And then the red and black dots are when this source was observed by the Hubble Space Telescope, which can collect more light. It looks a lot brighter. From that, you can also get a much more accurate position and size of this object as well, in order to get an estimate for the mass of the object that did the lensing, the brightening. Now, one paper claims that this object that did the lensing is definitely bigger than the maximum allowed mass of a neutron star at around about 3-ish times the mass of the sun, making it a black hole. Whereas the other paper claims it's somewhere between 1.6 and 4.4 times the mass of the sun, meaning it's either a neutron star or a black hole, but still something dark that we can't see. So there's a little bit of a disagreement between these two papers that use the exact same data sets, just analyzed in a different way, but still it proves that at least it is possible to find these rogue dark objects in this way. The hope is that we'll find more of these things either with the Ogle survey or with the brand new soon to come online LSST at the Vera Rubin Observatory, so that we can try and put some numbers on how many of these isolated neutron stars, black holes, these dark objects are there in the Milky Way. And finally, from black holes in the Milky Way to a supermassive black hole in a distant galaxy that is growing at a faster rate than it should be able to do. This was a study by Onkun and collaborators who were searching in survey data of the southern sky for binary stars, but instead found the brightest quasar ever seen. A quasar is what we call a growing supermassive black hole. Again, just like with the less massive black holes in the Milky Way, you have matter spiraling in, it's accelerated to huge speeds, and then it starts to glow across UV, optical, and X-ray light. So weirdly, that means that growing supermassive black holes are actually some of the brightest objects in the entire universe. And you might be thinking, well, how did we not know that this object existed already? How do you miss the brightest of the brightest objects in the entire universe? Well, first of all, the galaxy that this supermassive black hole was in the center of was 7 billion light years away when the light that we're detecting now actually left that galaxy, so it's very tiny on the sky. Plus, that light has obviously gotten fainter and fainter and fainter as it's traveled further and further through the universe, so it just blends with sort of all of the background stars and galaxies in the rest of the sky. It was only when Onkun and collaborators realized that it was a lot bluer than the rest of the things that they were seeing in the sky, i.e. it had a lot more higher energy, shorter wavelength light being released, like into the UV and X-ray side of things, that they realized that this object was something completely different than what they were actually looking for. They then used both the South African Astronomical Observatory and the Australian National University 2.3 meter telescope at Siding Springs Observatory to get a spectrum of the light from this object. Again, where you split that light through a prism to get that trace of how much there is of each color or wavelength. And that then revealed this characteristic shape that identifies this object as a quasar. It also revealed how distant it was from how much the light was redshifted. These are known as emission lines. They come from the different gases and they're always emitted at a very specific wavelength, so they can use these as marker points to know how much the light has been redshifted. With the redshift, you can then correct for distance, for how far that light has traveled and therefore how much fainter it's got. So you take the apparent brightness that we see and calculate the actual intrinsic brightness, how bright it truly is. And they found that that quasar was 100 trillion times more luminous than the sun. But also from this spectrum, they were able to estimate the black hole mass because these emission lines are given out by the gas that's spiraling around the black hole. And as I said, that material is given out at a very specific wavelength or color that can then be Doppler shifted, either blue shifted as the material that's giving out the light comes towards you as it's spiraling around the black hole, and then red shifted as the material that's giving out the light spiraling around the black hole moves away from you. And so what should be a very sharp peak at one specific wavelength gets smeared out. And if you can measure how much it's smeared out by, you can measure how fast the material is going and therefore know how massive the thing is the material is moving around, and therefore work out how massive is the supermassive black hole. So doing this, Onkun and collaborators found a black hole mass of 2.6 billion times the mass of the sun, which given how bright it is, means that this supermassive black hole is growing by 35 suns worth of matter every single year, which is 1.4 times more than the maximum amount that it should be able to grow at, assuming that, all the forces of gravity pulling inwards and then the force from radiation pressure pushing outwards are all balanced. So all of that UV and X-ray light that's being given off can actually act like a wind to push material back away from the black hole, regulating how fast it can grow at. So clearly this supermassive black hole gets around that balance somehow and manages to accrete, take in more material every single year. And that actually could be explained instead by the fact that the efficiency of converting the mass into energy, remembering E equals mc squared, mass and energy equivalent, perhaps that efficiency is actually higher. And so there isn't as much material as we think, but it's still very, very luminous, which is why we've been able to spot it. Or perhaps some of the light is lost beyond the event horizon rather than contributing to that wind outwards, so there's not as much radiation pressure and the balance is still maintained. Or it could just be something as simple as this system isn't symmetric, the same in all directions, which is how we have to model it to be able to get at numbers, like 35 suns worth of material every year for us to be able to put an estimate on that. Instead it could just have big clumps of material in sort of this disk that's spiraling around the black hole, or it could be a whole host of explanations, right? So further study of this object will help us, narrow down what actually is going on here so we can better understand, what is the maximum rate at which supermassive black holes can grow. Alright, that's it for Night Sky News for this month. I'll be back with the Night Sky News in July when we will finally have images from the James Webb Space Telescope. The long wait is finally over, so make sure you subscribe so that you don't miss me going through, what we can see in the images and what we've learned from them. In the meantime, if you snap an image of the night sky, send them my way over on social media because I'd always love to see them and I will share my favorites. Until next week, everybody, happy stargazing. Before we get to the bloopers, a big thank you to Wren for sponsoring this video. Wren.co is a website that makes it easy to calculate and offset your carbon footprint. And one thing I love about my job as an astrophysicist is how much I get to travel for it. It's a lot of long haul flights on top of what I want to do for my vacation travel as well. So I'm very concerned about my personal contribution to the climate crisis, the scientific evidence for which is just impossible to deny. So I want to take action, and I can do that with Wren. All you have to do is answer a few questions about your lifestyle to find out what your carbon footprint is and how to reduce it. Now, no one can take their footprint down to zero, but whatever's left, you can offset by donating to a huge range of carbon reducing projects. Since my impact mainly comes from CO2 injection due to travel, I particularly like the projects which aim to remove CO2 from the atmosphere, like this mineral weathering project in Scotland, which buys and reforests degraded land, but it also puts down crushed basalts which react with CO2 dissolved in rainwater to create solid carbonate, which locks away that carbon in rocks for millions of years to come. We all know it's going to take a huge collective effort for us to reverse the damage that us humans have done to the environment and the climate. And if you're like me and you're concerned about your carbon footprint and you want to be involved in that effort, you can start learning how today by clicking on the link to Wren in the video description down below. The first 100 people that sign up via that link will get 10 extra trees planted in their name. So thank you so much to Wren for sponsoring this video. And now, roll those bloopers. Change to the images that they're taking with the telescope. Just a slight degradation to the images. Degradation. No.
Gradation.
That's not even saying duh, it's just saying gradation.
Gradation.
Degradation. Degradation.
Gradation.
I'll just say the image has been slightly degraded. That's the easier thing to do. Or geological process that can produce phosphine on Earth, or phosphine? Not a word. But rogue black holes don't do that. We don't think that the material in interstellar space... Interstellar? If I only could make a deal with God, I'd get him to swap our places. We got a rogue black hole with Hubble. That's 4.4 solar masses.